Do you have any question? Do you have any question?
No, sir.
Okay.
You are not class starting.
Sorry, I could not hear you clearly.
Sir, start the class because time is.
Okay. The class will start soon. We'll wait for 2-3 minutes. Let the people come. Then we'll start. Okay. So today we'll discuss about classical mechanics and Lagrangian dynamics. Are you all familiar with Lagrangian dynamics? Yes or no?
Almost, sir.
Okay. So let's define action. What is action? Action is defined as integral L dt. Okay. T is the time and S is action and L is Lagrangian. Right? Now let's say there are some paths. Okay. Okay. These are some paths. And this is the initial position and this is the final position. Okay. So the arrows are like this. So this is time ti, the initial time. This is at final time tf. Now notice one thing, that the coordinates or the positions at the initial and final times for all the paths are same, right? This is clear. Okay. So let's say the coordinates at initial time ti for all the paths are q equal to qi, and similarly q equal to qf at t equal to tf for all the paths. Okay, so these are the initial and final conditions.
Sir, Q equal to Qi, time T equal to Ti,
So
not Tf.
hmm, this should be ti, right? Good. Now you have to make this action extremum. What does this mean? So you have to consider the configuration or the path for which the action is extremum. So you have to do this. Now what is this quantity? Okay, so let's consider this thing. Delta s equal to 0. Okay, so delta of integral L dt will be 0, right? Now L, this Lagrangian, will consider it is some problem. This L is function of q, q dot and t. Okay, so this delta L is equal to del L del q into delta q plus del L del q dot into delta q dot. Now we'll assume that this delta t is equal to 0. Why can we assume that? Because for all the paths you have seen, the time taken from for going from this point, the first point to last point, are equal, right? So this delta t is 0. So this will take 0. Now what is q dot? Q dot is equal to dq dt. here we'll interchange these two things, this delta and d dt. Okay, this is clear. I have just used differentiation.
Sir, repeat again.
Sorry, repeat
Sir, repeat
this part.
again.
This part.
Not this. Fully start.
Repeat this part. Which part?
No, no, sir. Go above. Yeah.
Which part? Delta L.
Uh,
Delta L thing.
yes.
Okay.
Yes, sir.
Okay. Okay. Fine. So you have to find out the change in L, right? So this is delta L. Delta L. So this L is a function of Q dot and T. So delta L will be del L del Q into delta Q plus del L del Q dot into delta Q dot plus del L del T into delta T, right? Now I have said here delta T equal to 0 because the time taken for going from the first point to last point are equal for all the paths. This is just an assumption. Okay. So what we have found, delta L equal to del L del Q into delta Q plus del L del Q dot into delta Q dot. And what is Q dot? Q dot is equal to dq dt, right? Now what I have done here, I have kept the first term as it is, and the second term I have used this thing delta of dq dt equal to ddt of delta q. Okay, just interchange the delta and ddt. Okay, so I have written it like this, and in the second term what I have done here, I have taken ddt of, so what is ddt of del L del q dot into delta q? This is equal to ddt of del L del q dot into delta q plus del L del q dot into ddt of delta q, right? So I've written that. That's just simple thing. That's all. So we have found this thing. So this is actually delta L. So delta L dt equal to 0. Now replace this thing here. Now consider the second term of this equation. Okay? Only the second term. So the second term is this. Now if you integrate it, then you will get this at Ti and Tf, right? Now I have told before that q equal to qy for all the paths at t equal to ti and q equal to qf for all the paths at t equal to tf. So what is the value of delta q at t equal to ti? Can anyone tell me?
QI, sir.
Q equal to qy for all the paths. This is constant, right? So what is the difference in q at t equal to ti? This will be 0, right? Because for all the paths this is same. Similarly for at t equal to tf, for all the paths this q is constant. This is constant. So what is the difference between the value of q for different paths? This will be 0 because this is constant. So this delta q at t equal to ti and t equal to tf are 0. So this term is 0 because delta q at t equal to tf 0 and also delta q at t equal to ty is 0. So the second term is 0. Now from the first and last term we get this. Okay, and this equation is satisfied only if del L del q equal to ddt of del L del q dot, and this equation is called Euler-Lagrange equation, and this equation can be used to find out the equation of motion for particles, right?
सर
Yes.
मैंने आपकी क्लास आज ज्वाइन की है, उससे पहले मुझे पता नहीं था। तो इससे पहले वाली क्लास में आपने डी-एलेम्बर्ट प्रिंसिपल पढ़ा
Sorry.
दिया था? डी-एलेम्बर्ट प्रिंसिपल पढ़ा दिया था क्या इससे पहले वाली क्लास में?
No.
सर आप कैसे पढ़ा रहे हो, सिलेबस वाइज?
No. 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 We are just told to solve some problems from previous year gate papers. Okay, that's all. This is
सर
just for your convenience.
सर मतलब सारे टॉपिक्स कवर करवा दोगे है ना?
No, no, no. We are just told to solve some previous year problems of GATE exam, GATE physics. That's all.
Yes, sir. You will give some information about these topics related to syllabus.
Right, right. I will solve some problems. You will see now.
Okay, sir. Thank you.
Okay. So
Sir,
let's. Sorry.
I think
Hmm.
we go through syllabus
Okay.
because it will help also.
But we were instructed to do like this. Okay. So if you have any suggestion, then you can send an email to NPTEL team. They can consider your
सर एनपीटीएल
request.
एक
Okay.
बार आप मेल टाइप कर दो ऐसे मैसेज बॉक्स इनबॉक्स में।
NPTEL GATE team.
एनपीटी
So from where you have got this information about this class?
एनपीटीएल
NPTEL,
वेबसाइट,
right? Oh, so in the website you will see there will be
गेट पोर्टल वेबसाइट पे मिलेगी ना
right, right,
इसकी?
right. In the gate portal there will be one email ID, right?
यस यस सर, थैंक यू सर।
There you can call. That's all. Okay. Someone has written in the chat the email ID.
Hello.
Hello.
Good evening.
Hmm.
Sorry to interrupt you, but I'm from NPTEL Gate department. So if
Okay.
you have any query, you can just reach out to me. I'm here.
Okay. Okay.
I'm
Fine.
available.
Hmm. I think one student was asking something about NPTEL, right?
यस यस सर।
If you have any query, then you can contact her also. Okay. So now I will solve a problem.
Hello everyone. In this video, I shall discuss the solution of question number 44 of GATE Physics 2021. This is a multiple select question. A uniform block of mass capital M slides on a smooth horizontal bar. Another mass small m is connected to it by an inextensible string of length L of negligible mass and is constant to oscillate in the xy plane only. Neglect the sizes of the masses. The number of degrees of freedom of the system is 2 and the generalized coordinates are chosen as x and theta as shown in this figure. Px and p theta are the generalized momenta corresponding to x and theta respectively. Then we need to find out the correct options. Let's solve this question. The length of the string is small l and it is at an angle theta with respect to the vertical direction. In the Cartesian coordinate, the mass small m is at position x1, y1. Here x1 turns out to be x plus L sin theta and y1 turns out to be L cos theta, where x is the distance of mass capital M from the origin. The kinetic energy of the mass capital M is equal to half into capital M into x dot square, and we assume that the mass capital M is at potential energy V1 equal to 0. The kinetic energy of the mass small m is equal to half into small m into x1 dot square plus y1 dot square, and the potential energy of the mass small m is equal to minus mg y1. The Lagrangian of the system is equal to T1 plus T2 minus V1 minus V2, where T1 and T2 are the kinetic energies of the masses M and m respectively, and V1 and V2 are the potential energies of the masses M and m respectively. Here we put the values of T1, T2, V1 and V2. Then we obtain the Lagrangian L equal to half into M into x dot square plus half into m into x1 dot square plus y1 dot square plus mg y1. Now x1 is equal to x plus L sin theta and y1 is equal to L cos theta. So x1 dot is equal to x dot plus L cos theta into theta dot, and y1 dot is equal to minus L into sin theta into theta dot. Putting the values of x1, y1, x1 dot and y1 dot in the expression of the Lagrangian, we obtain the Lagrangian L equal to half into M into x dot square plus half into m into x dot plus L cos theta into theta dot whole square plus half into m into L square into sin square theta into theta dot square plus mgl cos theta. After some simplification, this Lagrangian L can be written as half into M into x dot square plus half into m into x dot square plus ml cos theta into x dot into theta dot plus half into m into L square into theta dot square into sin square theta plus cos square theta plus mgl cos theta. Here sin square theta plus cos square theta is equal to 1. So this can be simplified to L equal to half into M plus m into x dot square plus m into L into cos theta into x dot into theta dot plus half into m into L square into theta dot square plus mgl cos theta. Now the generalized momentum corresponding to x px is equal to del L del x dot, which turns out to be M plus small m into x dot plus small m into L into cos theta into theta dot. In option A, it is given that px equal to M plus small m into x dot plus small m into L into cos theta into theta dot. So option A is correct. The generalized momentum corresponding to theta p theta is equal to del L del theta dot, which is equal to small m into L into cos theta into x dot plus small m into L square into theta dot. But in option B, it is given that p theta is equal to small m into L square into theta dot minus small m into L into cos theta into x dot. So option B is not correct. Now let's find out the equation of motion corresponding to the x coordinate, which is given by del L del x equal to ddt of del L del x dot. The Lagrangian L is independent of x, so del L del x is 0. On the other hand, del L del x dot is equal to M plus small m into x dot plus small m into L into cos theta into theta dot. Now px is equal to M plus small m into x dot plus ml cos theta into theta dot. So the equation of motion turns out to be dpx dt equal to 0. This means px is constant. In option C, we have px is conserved. So option C is correct. Now let's also calculate the equation of motion corresponding to the coordinate theta, which is given by del L del theta equal to d dt of del L del theta dot. Here del L del theta dot is equal to p theta. So the equation of motion turns out to be p theta dot equal to del L del theta. Now del L del theta is equal to minus small m into L into sin theta into x dot into theta dot minus small m into g into L into sin theta, and this is equal to p theta dot. So p theta dot is not equal to 0. This means p theta is not conserved. In option D, we have p theta is conserved. So option D is not correct. So we have found that option A and option C are correct. So in this question, option A and option C are correct.
Okay, so we are discussing this question, right? So here there are two independent coordinates, x and theta. So there are 2 degrees of freedom, right? And the distance from this mass capital M is x from this origin O. Okay, and this the distance of the mass small m from this mass capital M is L. This is actually a string which is connected from here to the mass small m. Okay, and the string is at angle theta with respect to the vertical direction. Okay, so what will be the distance? This distance, this will be equal to L sine theta, right? And this I will call I will call the position of the mass small m as x1 comma y1. So x1 is equal to x plus L sine theta, right? And what is y1? Y1 is equal to L cos theta, because this distance is L cos theta. Okay, simple. Now what is the kinetic energy of the mass capital M? This is equal to just half m x dot square. Here mass is capital M. Okay, so the kinetic energy of the mass capital M is T1, which is equal to half capital M x1 dot square. And I will consider that the mass at of capital M is at potential energy 0. Okay, so this is the 0 level of the potential energy. Okay, I will assume that. Okay, now what is the kinetic energy of the mass small m? This will be simply equal to half into small m into x1 dot square plus y1 dot square. And what is v2? The kinetic potential energy of the mass small m. This will be equal to minus small m into g into y1. Why is there minus sign? Because I have said this level, this the mass capital M at 0 potential, okay, and this the mass small m is at lower position than this position, so there will be minus sign, right? And here I have used this x1 equal to L x plus L sin theta and y1 equal to L cos theta. I have just replaced them here. Now what is Lagrangian? This the Euler-Lagrange equation can be satisfied with the total kinetic energy minus total potential energy as the Lagrangian, right? So the total kinetic energy is T1 plus T2. Similarly, the total potential energy is V1 plus V2. So I have just replaced T1, T2, V1 and V2 here. Then what I have done, x1 equal to this thing and y1 is equal to this. Just find out x1 dot and y1 dot. So what will be x1 dot? X1 dot will be x dot plus L is constant, so L, then differentiation of sin theta which is cos theta, then differentiation of theta with respect to time which is theta dot, right? Similarly, what will be y1 dot? Y1 dot will be minus L sin theta into theta dot. Here L is constant again. So just replace this x1, y1, x1 dot and y1 dot in the expression of the Lagrangian and then simplify it. Okay. Then I have obtained this equation. Now what is generalized momentum? Generalized momentum is defined as, let's say for the coordinate x, what is generalized momentum? Generalized momentum is px and it will be equal to del L del x dot. This is just a definition of generalized momentum. Okay, so just find out del L uh, del x dot from this expression. So this will be equal to this thing, and in option A it is given that px is equal to the same thing, so option A is correct. Similarly, you can find out also the generalized momentum in theta, which is equal to p theta. P theta is again del L del theta dot. Okay, and from the expression of the Lagrangian, you can simply find out the value of p theta, the generalized momentum corresponding to theta. But in option B, it is given that there is a minus sign here. Okay, but here but we have found it is there is plus sign, so this is incorrect. Option B is incorrect, and as I have explained before, that the equation of motion can be found from this Euler-Lagrange equation. So there are two degrees of freedom, so there will be two Euler-Lagrange equations. One is for coordinate x and the other is for coordinate theta. So let's find out the Euler-Lagrange equation for the coordinate x. So here see one thing, this Lagrangian is independent of coordinate x, right? So del L del x is 0. So del L del x is 0. And what is del L del x dot? This turns out to be px, right? So dpx dt equal to 0. This means px is a conserved quantity. So in option C we have px is conserved. So this is correct option. And let's also find out the Euler-Lagrange equation corresponding to the coordinate theta, which is again this. And as I have told before, del L del theta dot is equal to p theta, the generalized momentum corresponding to theta. And here we have d dt. So d p theta dot will be equal to del L del theta. And del L del theta is this, because here this Lagrangian depends, explicitly depends on theta. See here. So del L del theta is not equal to 0. This means p theta dot is non-zero. So p theta is not a conserved quantity. This means, so option D is incorrect. What is option D? Option D, In option D we have p theta is conjugate. So option D is not correct because p theta is not a conjugate quantity. So we have found that option A and option C are correct. Okay. Any question?
No, sir.
Okay. If not, then let's solve another problem. Now.
Hello everyone. In this video, I shall discuss the solution of question number 42 of GATE Physics 2022. This is a multiple choice question. If x dot into y dot plus alpha xy is a constant of motion of a two-dimensional isotropic harmonic oscillator with the Lagrangian L equal to m by 2 into x dot square plus y dot square minus k by 2 into x square plus y square. Then we need to find out the value of alpha. Let's solve this question. So in this question we have L equal to half m x dot square plus y dot square minus k by 2 into x square plus y square. The Euler-Lagrange equation for the coordinate x is given by del L del x equal to d dt of del L del x dot. Del L del x is equal to minus kx. Del L del x dot is equal to m x dot. So we have obtained m x double dot equal to minus kx. Now the Euler-Lagrange equation for the coordinate y is given by del L del y equal to d dt of del L del y dot. Del L del y is equal to minus ky and del L del y dot is equal to m y dot. So we have m y double dot equal to minus ky. In this question, it has been given that x dot into y dot plus alpha xy equal to constant. So d dt of this quantity is 0 as the differentiation of a constant is 0. Now if we differentiate this quantity with respect to t, then we'll get x double dot into y dot plus x dot into y double dot plus alpha into x dot into y plus alpha x y dot equal to 0. Here we have used these two equations, mx double dot equal to minus kx and my double dot equal to minus ky. After some simplification, we obtain that minus k by m into x y dot plus x dot into y plus alpha into x dot into y plus x into y dot equal to 0. So alpha minus k by m into xy dot plus x dot y equal to 0. So this equation is satisfied for alpha equal to k by m. So in this question, the value of alpha is k by m. So option A is correct.
So this was the question, right? So in this question, the Lagrangian is given to you. Lagrangian is m by 2 into x dot square plus y dot square minus k by 2 into x square plus y square, right? And you have also
Sir, there is no need to explain this question. You have already explained.
this is completely clear, right? Okay,
Yeah.
fine. So here I think I need to explain it just this thing only. Here I have used this x double dot equal to minus kx by m and y double dot equal to minus ky by m, because the I have found the equation of motion corresponding to the coordinate x and y as x double dot equal to minus kx by m and y dot equal to minus ky by m. That's all. And here as this is constant, you have to take differentiation of this thing and set it to 0, because you know the differentiation of a constant with respect to time is 0. That's all. Okay. So let's solve another question.
Hello everyone. In this video, I shall discuss the solution of question number 42 of GATE Physics 2016. This is a multiple choice question. The Lagrangian of a system is given by L equal to half m L square into theta dot square plus sine square theta phi dot square minus mgl cos theta, where m, l and g are constants. We need to find out the conserved quantity. Let's solve this question. In this question, we have L equal to half m L square into theta dot square plus sine square theta phi dot square minus mgl cos theta. Let's find out the generalized momentum p theta, which is given by del L del theta dot. So P theta is equal to m L square theta dot. P phi is equal to del L del phi dot. This is equal to m L square sine square theta into phi dot. Now let's find out the equation of motion in terms of theta and phi. For the coordinate theta, we have del L del theta equal to d dt of del L del theta dot. Now del L del theta is equal to mgl sin theta plus ml square sin theta cos theta into phi dot square. On the other hand, del L del theta dot is equal to ml square theta dot. Now p theta is equal to ml square theta dot. So dp theta dt is equal to mgl sin theta plus ml square sin theta cos theta into phi dot square. So dp theta dt is not equal to 0. So p theta is not a conserved quantity. Now let's find out the equation of motion for phi. This is given by del L del phi equal to d dt of del L del phi dot. Now the Lagrangian L is independent of phi, so del L del phi is 0. On the other hand, del L del phi dot is equal to ml square sin square theta into phi dot. So the equation of motion is given by d dt of ml square sin square theta phi dot is equal to 0. Now m and L are constants. So we have d dt of sin square theta into phi dot equal to 0. This means sin square theta into phi dot equal to constant. So in this question, sin square theta into phi dot is a conserved quantity. So option A is correct.
Okay, so this was the question. So there, here the Lagrangian is a function of theta and phi, right? So Lagrangian is equal to half into m L square into theta dot square plus sine square theta into phi dot square minus mgl cos theta, where m, L and g are constants. Okay, so let's find out the generalized momenta corresponding to theta and phi, because if the Lagrangian is independent of some coordinate, then the corresponding generalized momentum will be conserved quantity, right? Because you see here, here the Lagrangian is independent of phi. Del L del phi is 0 because there is no explicit dependence on phi for this Lagrangian. So del L del phi is 0. And what is del L del phi dot? This is equal to p phi, right? And p phi is the generalized momentum corresponding to the coordinate phi. So d dt of p phi is 0 because on the left hand side del L del phi is 0, and so this means p phi is a conjugate quantity. And what is p phi? P phi is equal to del L del phi dot, and L is this thing. So del L del phi dot will be equal to m L square sine square theta into phi dot, right? And so this is a conjugate quantity, and m and L are constants. So you have sine square theta into phi dot constant, right? So sine square theta into phi dot is a conjugate quantity. Any question?
No, sir.
I think it's completely clear. Okay, so let's solve another question.
Hello everyone. In this video, I shall discuss the solution of question number 10 of GATE Physics 2017. This is a multiple choice question. If the Lagrangian L0 equal to half m dq dt whole square minus half m omega square q square is modified to L equal to L0 plus alpha into q into dq dt, then we need to find out the correct statement. Let's solve this question. First consider that the Lagrangian L0 equal to half m into q dot square minus half m omega square q square, where q dot is equal to dq dt. Now let's find out the canonical momentum. The canonical momentum P naught is equal to del L0 del q dot, which is equal to m q dot. Now let's also find out the Euler-Lagrange equation, or the equation of motion. This is given by del L0 del q equal to ddt of del L0 del q dot. Now del L0 del q is equal to minus m omega square q. On the other hand, del L0 del q dot is equal to m q dot. So we have m q double dot plus m omega square q equal to 0, or q double dot plus omega square q equal to 0. This is the equation of motion if the Lagrangian is given by L0. Now let's consider the Lagrangian L, which is equal to L0 plus alpha into q into dq dt, and dq dt can be written as q dot. Here L0 is given by half m q dot square minus half m omega square q square. So the canonical momentum P is equal to del L del q dot, which is equal to m q dot plus alpha into q. And we have seen before that P naught, the canonical momentum when the Lagrangian is L naught, is equal to m q dot. So P equal to P0 plus alpha q. So P is not equal to P naught. It means the canonical momentum does not remain same when the Lagrangian is changed from L dot to L. Now let's find out the equation of motion when the Lagrangian is L. So in this case, the equation of motion can be obtained from this equation del L del Q equal to d dt of del L del Q dot. Here del L del Q is equal to minus m omega square Q plus alpha Q dot, and del L del Q dot is equal to m Q dot plus alpha Q. Now ddt of mq dot plus alpha q is equal to mq double dot plus alpha q dot. So we have minus m omega square q equal to m q double dot or q double dot plus omega square q equal to 0. So this is the equation of motion when the Lagrangian is L. So if the Lagrangian is changed from L0 to L, then the equation of motion does not change, but the canonical momentum changes when the Lagrangian is changed from L0 to L. Thus, in this question, we found that option B is correct.
Okay, so this was the question, right? So where initially the Lagrangian was L0 or L0 equal to half into m into dq dt whole square minus half m omega square q square. Okay, and here I will write dq dt as q dot. Okay. Now what is the canonical momentum for this Lagrangian when the Lagrangian is L0? This is P0. P0 is given by del L0 del Q dot, right? So this is equal to m Q dot. And what is the equation of motion? Again, it is found from Euler-Lagrange equation, which is equal to del L0 del Q equal to ddt of del L0 del Q dot. Del L0 del Q is equal to minus m omega square Q, and del L0 del Q dot is equal to m Q dot. Just differentiate the Lagrangian with respect to Q and Q dot here and replace them. So we have Q double dot plus omega square Q equal to 0. So this is the equation of motion when the Lagrangian is L0. Now this Lagrangian is modified to L0 plus alpha Q into Q dot. So this is the new Lagrangian, right? This was the old Lagrangian L0, which is equal to half m Q dot square minus half m omega square Q square, and this term is new. This term is now added to it, right? Alpha Q into Q dot. So what will be the canonical momentum now? This will be equal to del L del Q dot, which is equal to P, which I will call P. Okay. So this is equal to m Q dot plus alpha into Q, and the previous generalized momentum was P naught or P0, which is equal to m Q dot. Now the new uh, generalized momentum will be equal to P0 plus alpha into Q. So the generalized momentum does not remain constant when the Lagrangian is changed. Okay, but what happens to the equation of motion or the Euler-Lagrange equation? Now again the Euler-Lagrange equation is given by this thing, and what is del L del Q, this will be equal to minus m omega square Q plus alpha into Q dot, right? And what is del L del Q dot? This will be equal to m Q dot plus alpha into Q. So these are like this. Now we have ddt on the right hand side of this quantity. So if you take differentiation of this quantity with respect to time, then you will get m into Q double dot plus alpha into Q dot, right? And here we have alpha into Q dot on the left hand side and alpha into Q dot on the right hand side. So these two terms cancel out. So finally we have Q double dot plus omega square Q equal to 0. So this means the equation of motion remains same, but the canonical momentum changes. So in this question, this is the option B, which is correct. And I think there is another way to solve this problem, and that's very simple and short also. Short trick to solve this problem. Now I'll show it to you. But before that, any other question?
No, sir. No question.
No question. Okay. So now I'll show the simple way to solve this problem. Okay. So if you want to find out the canonical momentum, then you, just follow these things. Just differentiate the Lagrangian with respect to Q dot for both L0 and L. That's all. But mm, if the Lagrangian is modified to this, then if you want to check whether the Lagrangian, whether the the equation of motion remains same or not, then I have a short trick for you. So I'll show it now. So what is the new Lagrangian? This is equal to L0 plus alpha Q into dq dt, right? Now I will write the second term as this: alpha by 2 into ddt of q square, because ddt of q square is equal to 2 into q into dq dt, and here we have alpha by 2, so this will be equal to finally alpha into q into dq dt, right? So this means the new Lagrangian is equal to the old Lagrangian plus ddt of half alpha q square, and here alpha is a constant and q is the generalized coordinate, and there is one, let's say if some function which is a function of the generalized coordinate and time. So if the Lagrangian is modified by the total time derivative of some function of generalized coordinate and time, then the equation of motion remains same. And here what happens, this function f should be a function of generalized coordinate and time, and here the function f is half alpha q square, so this is a function of generalized coordinate only. So, and here we have d dt, the total time derivative. So this thing is satisfied, right? So the equation of motion remains same as the Lagrangian is of this form. Sorry. Today we are already running out of time. So next day, if we have some time, then I will show whether this is really satisfying the same Euler-Lagrange equation or not, or the equation of motion remains same under this transformation or not. Okay, this actually happens if the Lagrangian is modified by total time derivative of a function of generalized coordinate and time, then the equation of motion or the Euler-Lagrange equation remains same. Okay, any other question?
No, sir.
Okay, so if not, then we'll stop here today. We'll continue our discussion on Hamiltonian dynamics next week, next Saturday at 6 p.m.
Yes, thank you, sir.
Thanks.
Thank you,
Thanks
sir.
everyone.
Good night.
Thanks everyone for joining. Bye.